Okay. This is 6.1 to 6.3 grids and tops. Okay. First question. You have a sequence un defined recursively by un equals 4un minus 1 plus un minus 2 with u1 equals u2 2 and u2 equals 5. What is u4? This is question, always we see it. Always when you have a recursive definition, you have to work step by step. Okay, so before finding u4, I need to find u3. Okay, if I'm going to start over here, u3 is going to be equal to 4u2 plus u1. So it's going to be 4 times 2 plus u1. Sorry. So 4 times u2, which is 5, plus u1, which is 2. It's 22. So u4 is going to be 4u3 plus u2. So it's going to be 4 times 22 plus 5. So 88 plus 5, so 93. Let's check. It's correct. Okay. Question 10, 11, 14. 10. Okay. an is an arithmetic progression where a24 minus a8 is 176. What's the common difference? Okay. Always when you see an minus am, what the fuck? Yeah. Anyway, anytime you see an minus am, you're gonna use this formula. An minus am is equal to n minus m d. So obviously, we know that an minus m is 176. So 176 is equal to n minus md. So 24 minus 8 d. So it's gonna be 176 divided by 16. You get 11. Let's check. 10, 11. The third term of an arithmetic progression is 12, and the 10th term is 33. What's the 35th term? These questions are all from the quiz. So I'm going to go through it fast because we've had these before. So A3 is 12. A10 is 33. We want A35. Okay, first you need to find the difference. For to do that, I'm going to do A10 minus A3 is equal to n minus md. So A10 minus A3, we're going to use an minus am equals n minus md. So A10 minus A3, so 33 minus A3, which is 12, is equal to 10 minus 3 d. So you're going to get d is equal to 3. Now A35, how do we find it? Using the same formula. A35 minus let's use A10, is equal to 35 minus 10 d. So you're going to get A35 is equal to 25 times 3 plus A10, so plus 33. So 75 plus 3, which is 108. Yeah. Question 14, I think. Yeah. The first term of arithmetic progression is negative 4, and the 14th is 61. What's the sum of the first 20 terms? Okay. Sn is equal to n over 2 a1 plus an. But in this case, we don't have the 20th term, so we can use this formula. Right? Type. What's the difference? Let's find the difference. We know that a1 is equal to negative 4. And we know that a14 is equal to 61. So let's do a14 minus a1 is equal to n minus m d, right? So a14 61 minus a1 negative 4. See how it becomes minus is equal to n minus m d. So 14 minus 1 d. So 65 divided by 13, you're going to get d is equal to 5. Okay, now you know d is equal to 5, so let's do the sum of the first 20 terms would be n over 2, so 20 over 2, 2a1, so 2 times negative 4, plus n minus 1d, so 19 times 5. I'm going a bit fast because these are easy, and they were in the quiz also. So 10 times 2 plus 5 times 19, easy. Okay, 20. Okay. What's the common ratio of a geometric progression where G2 is 6 and G5 is negative 162? Always when you want to find the common ratio of any geometric progression, Gn over Gm is equal to r to the power of n minus m. Use this rule. This is what I use. Okay, So G5 over G2 is equal to R to the power of 5 minus 2. So it's going to be negative 162 divided by 6 is equal to R cube. This is our calculator. I'm very sleepy. Yeah, you get negative 27, and then R cube equals negative 27, so you're going to get R is equal to negative 3. These questions are very easy. Over here. Type question 21. The sum of the first 5 terms of geometric progression. This is 11 over k was the value of k. These questions were in the quiz, man. Okay. So the sum of geometric progression is equal to g1 times 1 minus r to the power of n over 1 minus r. Okay. So g1 4 times 1 minus r. What's r? Let's see. Negative 2 divided by 4 is negative 1 over 2. So the ratio is negative 1 over 2, which is just negative 0.5. Okay, so 1 minus 0.5 over to the power of n now. We're seeing the first 5 terms, so to the power of 5. Okay, over 1 minus 0.5. Let's do it on a calculator. Okay, so we have 1 minus 0.5 to the power of 5 over, sorry, negative 0.5 over 1 minus 0.5 times g1, which is 4. You get 11 over 4, so k is equal to 4. Question 22. What's the sum to infinity of geometric if first term is 48, the second term is 36? S to infinity is equal to g1 over 1 minus r. g1 is 48. What's r? We know the first and second term, they're consecutive terms. So to find the ratio, I can simply divide the second by the first. So 36 over 48. So you should get 3 over 4. So g1 over 1 minus r, so 48 over 1 minus 36 over 48 is gonna be 1 minus 36 over 48, 192. So answer 192. Question 24. 2022, question 24. Okay. And then we start with tops, right? Yeah, okay. Type. A ball is dropped on bounces such that each bounce is 50% of the previous bounce. So we know that r is equal to 0.5 because it's half. The first bounce reaches height of 6 feet. The height of the ball on the 8th bounce is what? So we want g8. g8 is equal to g1 times r to the power of n minus 1. So g1 is 6, r is 0.5 to the power of n minus 1, so 8 minus 1. So you can do 6 times 0.5 to the power of 7. You're going to get 3 over k. K is 64, right? 64. Okay, for part B and part C, many people solve this wrong, okay? What people do here, I'm going to show you what I do and what people do, okay? The total vertical distance traveled by the ball from when it first hits the ground until it hits the ground at the end of the 10th bounce is 3069 over n feet. Find the value. So this is obviously geometric progression. We want the total distance, so we're looking for the sum of geometric progression until the 10th term, right? So the sum of the 10 terms is g1 times 1 minus r to the power of n over 1 minus r. But since we're looking at the total vertical distance, we're going to multiply this by 2. Why? Because this, without multiplying by 2, will just tell you the distance going up. But also, it's distance traveled, so it's also, you need to consider the distance going down. Okay, so let's do this. g1 is obviously 6 feet. That's the first bounce. Times 1 minus r, which we found to be 0.5 in the question. The power of n. 10th bounce, so to the power of 10 over 1 minus 0.5 times 2. Let's do it on a calculator. 6 times 1 minus 0.5 to the power of 10 over 1 minus 0.5 times 2. You get 3069 over 128. Okay, so n is equal to 128. What do people do that pisses me off? This is what people do. They do g1 times 1 minus r to the power of n over 1 minus r. So what do they take g1 as? They take g1 as 12. I said, why? L, because before it got to 6 feet, it was double, because each bounce is 50%. So the first bounce 6, so the bounce before it was 12. E, I didn't, like, I got mad, because it's a coincidence here that the ratio is 50%. Okay, if in the exam, in the AMS, they still got 50%. So if in the exam she came and got you 25% or 40% or whatever, this will not work. Okay, so you have to use the way I explained here. No matter how many times the ball bounces, what's the total vertical distance? Find the smallest possible value. So how many? No matter how many times. So infinite number of times. What's that going to be equal to? G1 over 1 minus R. So it's going to be 6 over 1 minus 0.5. And don't forget, they're saying the total vertical distance. So you multiply by 2. So you're going to get, should be 24. Yes. Okay. Tops, we have a good 2 pages, 3 pages. So 2 pages only. That's not bad, one. 2 pages and a half. Okay. In arithmetic progression, the first term is 0.6. The fifth term is 5. And the last term is 109.5. Find the sum of all the terms of the progression. So before finding the sum of all the terms, we obviously need our constant difference, right? Let me go down a bit so I have some more space to work. Okay, we need a constant difference. So we have the first term is 0.6, fifth term is 5. If I let's do an minus am equals n minus md. You always use this to find the constant difference given any two terms, right? So an minus am, so a5, which is 5, minus am, which is a1, which is 0.6, is equal to n minus md, so 5 minus 1 d. So you're going to get 4.4 equals 4d. So you're going to get d is equal to 1.1. Type. We now know the difference. What do they want? They want the sum of all the terms. What's the sum of all the terms? It's equal to n over 2. You can use a1 plus n minus 1d, 2a1 plus n minus 1d, or a1 plus an, right? But for both these cases, I need to know what my n value is, right? So how do I find the n value? 109.5. How do I know what n value it is? We know two things. We know an is equal to the n plus b. We can find the general term and use that. Or you can use the formula an is equal to a1 plus n minus 1d. This is easier because I won't have to do an extra step here. I can just substitute and I can find what n is. Okay, so an, we know it's 109.5 is equal to a1, which is 0.6, plus n minus 1 times 1.1. Let's solve this. 109.5 minus 0.6, okay, divided by 1.1 plus 1. You're gonna solve. You solve, you're gonna get n is equal to 100. Type. Now we know n is equal to 100, so can I apply the sum? Yes, I can. N over 2. You can use a1 plus a1 n over 2 a1 plus n minus 1d. I'm gonna use a1 plus an. So sum is gonna be equal to 100 over 2 a1, which is 0.6, plus an, which is 109.5. So 50 times 100, 110.1, 5,505. Okay, question 26. A geometric progression has 3 terms, and I'm talking, so yeah, okay. It has 3 terms. The first term is 1500. The common ratio is 0.2. Arithmetic progression has 15 terms and common difference 0.2. Given that the sum of all the terms of the geometric progression is equal to the sum of all the terms of the arithmetic progression, find the first term and the last term of the arithmetic progression. So let's work on this step by step. The sum of the geometric is equal to the sum of the arithmetic. What's the sum of the geometric? It's equal to g1 times 1 minus r to the power of n over 1 minus r. What do we know? We know that it has 3 terms. The first term is 1500, and the ratio is 0.2, so we can actually find the geometric sum. So it's going to be g1, which is 1500, times 1 minus r, so 1 minus 0.2, to the power of n. We're talking about 3 terms, so to the power of 3 over 1 minus 0.2. Okay, so let's do this on a calculator. 1500 times 1 minus 0.2 to the power of 3 over 1 minus 0.2. 1860. So 1860 is the geometric. We know that this is equal to the sum of all the terms in arithmetic progression. So it's equal to Sn arithmetic, right? Which is n over 2 a1 plus an, or 2a1 plus n minus 1d. Let's see. We know that the arithmetic progression has 15 terms and common difference 0.2. Since I have the common difference, I'm going to use the sum formula that has common difference. So I'm going to use this one. Okay. So we know it's equal to 1860. We know it's 15 terms, so 15 over 2. 2a1, we don't know what a1 is, plus n minus 1d, 15 minus 1 times 0.2. Obviously we can find what a1 is equal to. So 1860 is equal to this, so 1860, you can solve it on your calculator, whatever you want. Okay, minus 14 times 0.2 divided by 2, you're gonna get a1 is equal to 122.6. They want the last term of the arithmetic progression, so they want a15. What's a15 equal to? Anytime you want the nth term, you can use dn plus b, or you can use a1 plus n minus 1d. Okay, so 122.6 plus 14, because n minus 1 times 0.2. 14 times 0.2, 125.4. So let's see what the answers are. So 122.6 for A1 and 125.4 for A15. Very easy. Question 27. The second term of a geometric is 16 and the sum to infinity is 64. Okay, so G2 is 16 and the sum to infinity is 64. Find the first term of the progression. So find G1. Okay, what is the sum to infinity? Sum to infinity is equal to G1 over 1 minus R. Can't I find R here? Of course I can, because I know what G1 is. 64 is equal to G1 16 over 1 minus R. So 1 minus R would be equal to, like I always tell you, you can swap the denominator with this answer. You can swap these always to solve. So 16 over 64. So R is going to be equal to 1 minus 16 over 64, which is 0.75. So that's what R is equal to. They want the second term. As the first term. What? First term? Yeah, my bad. I don't know how I was using G1 as G2. So anyway, let me fix this. The sum to infinity is G1 over 1 minus R. What do I know about G1? G1 is equal to G2 divided by R. Or you can do a different way. Or no, this is the only way that would work. Because if you use R as G2 over G1, you still don't know what G1 is, so you can't solve. Okay? So we're going to substitute G1. It's just G2 divided by the ratio, right? Over 1 minus R is equal to 64. Let's fix this. You're going to get 16 over R over 1 minus R is equal to 64. You can use any way to solve this equation. So I'm going to swap 64 and 1 minus R. Then 16 over R over 64 is equal to 1 minus R. You can take the 64 here. So it's going to be, you can solve whatever way you want. But I'm going to put 16. But if you don't know how to do this, just replace R with 1 and put it on a calculator. Huh? 16 over 64 R is equal to 1 minus R. This is where you cross multiply and solve. So you're going to 64. Now let's actually simplify this. It's going to be 3 over 4. I'll choose 3, so 3 over 4. This is 1 over 4. R is equal to 1 minus R. Cross multiply, you're going to get 4R minus 4R squared is equal to 1. And take it all to one side. Or actually, no, you want. Yeah, take it all to one side. You're going to get 4R squared. Just solve this as a quadratic. I want to walk you through how to solve a quadratic. You should know any. multiply, factor now, which numbers multiply to get, which numbers multiply to get 4, but add up also to get 4, obviously 2 and 2, so 4r and 2, 4r and 2, and since it's plus, so it's going to be minus minus equals 0, so you're going to get one solution, which is 2 over 4, which is 1 over 2, which is 0.5. So we want the first term. We know that the first term is just g2 over r, right? Obviously g1 is just g2 over r, right? Because g1, g2, g3, g4, g5, obviously g1 is just g2 divided by the ratio that was being multiplied by. So it's going to be 16 over 0.5, so you should get 32. 27, a1 equals 32. Here they just solved it directly, so that's why there's no, like, there's not a lot of working. They did it in their head, كيفهم. Okay, then they said the arithmetic progression has the same first and second terms as the geometric progression. So g1, which we found, is 32, and g2, which is given 16. Find the sum of the first 11 terms of the arithmetic progression. So we know that a1 is equal to 32, a2 is equal to 16. So obviously the constant difference is negative 16, right? Type, what's the sum of the first 11 terms? Sn is equal to n over 2. Since we don't have the 11th term, we're going to work with 2a1 plus n minus 1 d. So n over 2, 11 over 2, 2a1, so 2 times 32, plus n minus 1, so 11 minus 1, which is 10, times negative 16. Let's do this. We get 64 minus 160 times, 64 minus 160 first, times 11 over 2. You get negative 528. Let's see the answer. Negative 528. Okay, the first term of geometric progression is 270, and the fourth term is 80. So g1 is 270, g4 is 80. Find the common ratio. So we have g1 is 270, g4 is 80. How do you find common ratio? We know any gn over any gm is equal to r to the power of n minus m, which is equal to 4 minus 1, which is equal to 3. Anyway, so 80 over 270 is equal to r cubed. So it's cube rooted. You can get 2 over 3. So r is equal to 2 over 3. The sum to infinity of the progression, sum to infinity is g1 over 1 minus r. So g1 is 270 over 1 minus 2 over 3. We're going to do 270 over 1 over 3 because that's how it works. 810. Right? Okay. The second and third terms of the geometric progression are the first and the fourth terms, respectively, of the arithmetic progression. So, find the sum of the first 9 terms. So, they're saying the second term is the first term, and the third term is the fourth term. So, g2 is equal to a1, and g3 is equal to a4. Let's find g2. g2 is just equal to g1 times r, right? Because r to the power of n minus 1, so 2 minus 1 will be 1. Anyway, so it's going to be g1 is 270 times r, which is 2 over 3. You're going to get 180. g3 is equal to g2 times r, or you could say g1 times r squared. So I'll just say g2 times r. So it's 180, 2 over 3, 60 times 2, 120. So g2 is equal to 120. So a1 is equal to 180, a4 is 120. They want the sum of the first 9 terms. So obviously we need the difference first. So we have a1, 180, a4, 120. How to find the difference? a4 minus a1 is equal to n minus 1d. So a4, which is 120, minus 180 is equal to n minus 1d, so 3d. So negative 60 equals 3d, so d is equal to negative 20. Now can we find the sum? Of course, yes. Sn is equal to n over 2, 2a1 plus n minus 1 d. Right? So it's going to be 9 over 2, 2 times a1, which is we found here to be 180 plus L minus 1 D. So 9 minus 1 D, so 8 times D, which is negative 20. So let's see what we get. 360 minus 160 times 9 over 2. 900. Let's see, do we get 900? Yes. Question 29. Find the sum to infinity of the geometric progression. First three terms 0.4, 0.4 cubed, 0.4 squared, 0.4 to the power 5. So obviously, we're increasing by 0.4 squared every time, right? طيب. What's the sum to infinity? Sum to infinity is equal to G1 over 1 minus R, right? G1 is 0.4 over 1 minus R. What's R? Obviously, 0.4 squared. Why squared, Wadi? Because that's the ratio, not like the ratio itself is 0.4 squared, not 0.4, which is R and then R squared. No. It's just the ratio itself is 0.4 squared. So 0.4 over 1 minus 0.4 squared. So the answer is 10 over 21. Let's see. I don't know why this looks wrong. Yeah, 10 over 21. Okay. So equals 10 over 21. So over here, they told us now arithmetic. A1 is equal to 15. A2 equals 19. So immediately we can find out that the difference is 4. Right? The cost difference is 4. They're saying that the last term is the first term of the sequence that's bigger than 200. So it's the first number that's actually bigger than 200. So how do we know which is which? So to do this, I'm just going to use an is equal to a1 plus n minus 1d and plug in 200. Even though it's greater than 200, so I'm just going to plug in 200. And we'll see what decimal we get. So a1 is 15 plus n minus 1d. So we don't know what n is. So n minus 1 times 4. So you're going to 260. Hold up. So you're going to get, let's solve this. 200 minus 15. 200 minus 15 divided by 4 plus 1. So you get n is equal to 47.25 when you plug in 200. Obviously, we can't have a decimal for n, right? It has to be an integer. So in that case, it's the first term greater than 200. So after than 200. So obviously it's going to be, what's the biggest number closest to 47.25? 48. So n is equal to 48. What are they asking for? The sum. Okay, so we want the sum now of all these terms, because this 200 is the last term. So if it's 48, anyway, it's the sum of the 48 terms. So Sn is equal to n over 2, a1 plus 2a1 plus n minus 1d. So 15, 2 times 15 plus n minus 1d, 48 minus 1, so 47, d, which is 4. Let's see, 24 times open 30 plus 47 times 4. 5,232. Let's see. Yes. Okay, the eighth term of an arithmetic progression is 49, and the sum of the first terms is 20. So A8 is equal to 49, with the sum of the first 5 terms is equal to 20. So 5 over 2, 2a1 plus n minus 1 d is equal to 20. Find the first of the progression and the common difference. Okay, let's start substituting what we know. A8, or let's start here. N minus 1d for the first 5 terms, so it's going to be 5 over 2, 2a1 plus 4d, right? You can cancel out the 2 with these two 2's, so this is going to become 2d. So you're going to get 5a1 plus 10d, okay, is equal to the sum, which is 20. نحن for this one we also need to rewrite it in a formula. We're trying to find the first term and the common difference. Which one releases to the first term? Any an is equal to a1 plus n minus 1 d. So it's going to be a1, which is, we're trying to find it, plus n minus 1, so 8 minus 1 d. So we now have that 8 is equal to 49. So we have simultaneous equations. Okay, first one is this one. The second one is this one. a1 plus 7d is equal to 49. Now solve these both. You're gonna get, I'm sure you all know how to solve a simultaneous equation at this age. You're gonna get d equals equal to 9 and a1 is negative 14. Part B, find the value of n. Okay, the nth term of the progression is 4. Okay, so we know that an is equal to 4. What's an equal to? An is equal to a1 plus n minus 1 d. We said from the previous part that a1 is equal to what? Negative 14. Okay, so a1 is negative 14. So it'll be negative 14 plus n minus 1 times the difference, which we found is 9, is equal to the nth term, which is 4. So you're going to get 18 divided by 9, 2. You're going to get n is equal to 3. Let's check the answer. N is equal to 3. A geometric progression has a third term of 63 and a sum to infinity, which is 4 times the first term. Find the first term.